Hi, folks. My name is Colin Lee, and I'm here today to talk to you about your code security blanket. So let's dig in a little bit. Who is this guy in front of you? You're probably wondering. I've been an Android engineer for a long, long time on some pretty cool projects. I've been writing software for way too long time. And I was actually a security certifier when I worked at Amazon. So that gives me a little bit of a basis where I started to build up security skills while my primary job was software engineer. I'll dig into that more in a moment. And now today, I'm actually still conducting security reviews. I just completed one for a bank, which found plenty of interesting findings, which tells you that no matter how critical security is to your business, there's no guarantees that your coders are taking that into account. So it's very, very important that you have somebody on your team who understands security. Keep going here. So we actually, the concept of security blankets, you may or may not be aware, is actually like a comfort object that babies cling to when they're feeling scared or nervous. It makes them feel comfortable even when they're maybe shouldn't be, because in nature they could get eaten when they're hanging onto this thing. It's an irrational response, and I want to talk to you about how to improve your security posture so that you don't have an irrational response where you cling to some object or notion, rather that you look at security as something you can fix and be comfortable about for the right reasons. So here's what I'm going to cover. I only have 25 minutes, so I'm not going to be able to go through the entire OWASP manual or anything like that. We're going to talk a little bit briefly about learning how your code breaks and ways you might do that. How a code security review takes place and how I perform these. Some of the common mistakes you might make as a programmer and how to avoid them. And that's literally the only three things that I'm going to try to get done in 25 minutes. Again, this is not going to be the entire OWASP top 10 or the manual or any of that. So let's just start digging in. How does code break? Now, when you want to learn how code breaks, everyone thinks, well, I should just go to my security engineer. Maybe they can review all those hundreds of thousands of lines of code that we produce as a team, and they will find all the points where there could be an exploit or some kind of problem. And what's actually, no, it's not just somebody else's job. It's actually your job too as a programmer. What we ultimately want is to see more coders taking more of an interest in security. And what you'll find is a lot of the biggest companies with the best security entrust their coders, usually a few select individuals who are interested, to assess the security of their enterprise. And so even though they have security engineers, it's the coders who have the greatest responsibility to make the products secure. And the best way to learn how code breaks is to try breaking it. Now, I'm going to talk about CTFs because it's a great artificial way to very quickly get immersed into what security is. But you can also create your own network at home. You can try testing out vulnerabilities on your own machines. You could attend conferences and you can do lots of practice. So what is a CTF? A CTF is short for capture the flag. It's not that game you play as a kid where you'd yank a flag off a kid's hip. It's actually like a war game where you would practice breaking code, learning the ways that code breaks by actually doing it. And in a CTF, generally the teams might compete to see who can exploit the most flaws in that time. Sometimes they're scored. Sometimes they have a Jeopardy board style where it's different levels of difficulty. You can work your way up. There's so many different types of CTFs. But nearly every computer security conference has one. And I would say the vast majority of them are free and open to the public. So you should consider going to a security conference once just to even get your feet wet. It's a lot of fun, and I enjoyed it. I said, like learning a foreign language, immersion is the quickest way to get familiar with it. So so I was a code security reviewer. I still do that, and I worked at Amazon where I did that as my second job, and I'll get more into detail again soon. I'm going to talk about the security review process, some of the automated tools, how you'd use them, and also manual code inspections, and just talk a little bit about some of the process. So let's dig in here. I was a security certifier at Amazon. That means I was a part-time volunteer coder who reviews the code of other engineers and other apps. And it only took a 3-day training course. The intent is that the people joining this program are already interested in security. They already have some background in breaking code. And after you've done this course, they expect you to dive in, review somebody's code, find almost all of the flaws, and then they have an actual application security engineer who will double check your review the first time until you can get one done with a sufficient number of flaws exposed. So it's just a 3-day course. And then once you become a certifier, they'll then assign you several 3-month review projects throughout the year so that you're constantly assessing the security of something. You're constantly learning about security and trying new technologies and understanding how they work. And most of the training, like I said, is just learn as you do. You do code and architecture reviews, and then you go to Amazon's internal fake DEF CON conference called ZoneCon, which you probably can't find on Google even, because that's how secretive they are. And CTFs. You know, there's a lot of good CTFs out there. There's some that are mediocre, but it's hard to tell the difference. I guess, yeah, just try it. It's the best answer if you're interested in CTFs. So let's talk about the process that I go through when I review an app. I would generally start with an architecture review. At Amazon, that would actually be like an hour-long meeting / interview where you're interviewing the team that built this app. And that before the meeting, they've given you, they filled out a questionnaire. They've given you a map of how the app functions. And then we go to like an automated inspections. This is where you would run some tooling that will give you some of the security flaws suggested to you right away. You do your manual review. You're going to deliver your findings, engage a pen test if one is needed, which is pretty common. And then you fix or mitigate any issues that you were found, and then review annually. I'll go into a little more detail right here. So I started talking about this already, but the architecture review, again, is where the team describes how everything is put together. This is how you identify the places where you're going to focus heavily during a review. And during this meeting where you review the architecture, you're going to ask tons of questions about every piece of the map, what might be left out, what might not be fully described. You look hardest where all the components connect. You learn the trust boundaries, where it might only give you user permissions in one area of the app and then give you all the permissions in another. That's going to be an area where you want to spend a lot of your time. Then you look at how they're protecting your data when it's crossing boundaries or when it's sitting at rest on a disk somewhere. And then we have these automated inspections, lots and lots and lots of tools. This is not a complete list. There's more than like 3 dozen, I think. These are just some of the ones I've used in the past that are very good. And the automated tools are great for detecting likely flaws, but a human ultimately needs to analyze if they're legitimate or if they're a false positive because the code sees something that looks like a security flaw. Even if it's a false positive, there's cases where you look at it and you see this could be safer if they did this, and you still want to report those findings. So manual review is the next phase. That's where you actually pour over the code yourself. There's too many lines to look at every single one. So typically, it's great to start out from the OWASP checklist. Now, OWASP is the biggest, most useful industry organization for just describing how to go about security review. They do checklists, they do manuals, they do automated tools, and they're great. So if you follow the checklist, you're going to get a lot of the stuff that you're looking for. Another thing you do is you search the code. You do a lot of find operations on the code base, looking for anything related to passwords, anything about cookies, anything having to do with SQL queries and credentials. And these are going to be natural points where things break in any app. Fully custom encryption. So if anybody writes their own encryption from scratch saying that they know better than the entire internet, it doesn't necessarily mean they're crazy, but the vast majority of the times when somebody writes fully custom encryption, they're not taking into account things that a mathematician might find wrong with their implementation. And so it's almost always insecure. You're just not going to find out until your app is popular enough. So that's always an area to watch carefully and maybe push people in the right direction. Trust boundaries, again, are always important. And anytime you receive input from a user, even if it's like a HTTP parameter, which they didn't probably type out themselves, they could. And so you have to always treat anything that comes from the user or the client, the browser, your mobile client, as suspect. So finally, you're going to go in front of the team, deliver your findings. You have to verify if the flaws are real or likely, or if they're just a false positive. You're going to score everything. There's a CVSS, is the industry standard scoring method that helps you identify how urgent things are to fix, or how maybe, yeah. And then you're going to develop this detailed report. And once you've got the report, you disseminate to the team, give them time to read, and then meet with that team to discuss all the concerns you found. Once you've gotten through all of that, there's another phase where you can actually reach out to an external pen test team. And normally you would start this, because it takes many months to get on the schedule for a pen test, like at the beginning of your process. You just know you needed a pen test and start getting on their queue. And then this qualified external firm will then produce their own report that you can, then add to your own findings to improve the quality of the review. The advantage here is the team may find things that are easily found from the external interfaces of the app that could then help an attacker who doesn't know the code to, it will prevent an attacker who doesn't know the code from digging in and getting to get a good view of your network. Finally, you fix or mitigate your issues. Those CVSS scores are going to tell people which items actually need to be fixed immediately. You're going to have the team fix the most urgent or the easiest to fix issues, depending on their scores. And then you're going to want to mitigate issues. That's where you just make it less easy to exploit by making some changes to how things are performed. It may not be a full fix, but if the fix is too costly, if it is going to take the team a month out of their schedule, you can do that as long as you can put in some kind of a sign-off where that mitigation is reviewed every year. So we're going to talk about that every year at Amazon. And then again, they're a little secretive. So I think this is true. I've heard of a lot of companies that are that large. You're going to want to review all of those code and architecture changes to see if there's any new security flaws. You're also going to want to look at all the mitigations or sign-offs. Like, let's say that you did decide that even mitigation was too much. The team needs to get this thing out the door today. Well, you can get a sign-off, and the more critical the issue is, you probably want to go as high as the VP level to prevent sweeping any serious flaws under the rug. So as long as you're requiring sign-offs at a high enough level of the company, it's going to be a lot harder to continue to have security flaws that are ongoing and could be exploited. It's part of the problem of large companies nowadays that they're so mission driven, they have to deliver like right away, that security is always an afterthought. But if you have this process, then it'll eventually catch up. So here's some common mistakes. I'm not going to go through everything, just some of the ones that I think are maybe a little underrated or a little should be interesting to programmers. Memory management is the heart of a lot of problems. Type checking and using strong types can save your bacon. And I'll go into that more. Injection attacks with XSS, or this cross-site scripting, JavaScript and SQL. There's so many kinds of injection. Those are just 3. And then there's test code. When you write code to test your app, you really don't want that going into production. I'll tell you why. So memory management is when you're dealing with languages like C, C++, and assembly. A lot of these languages have no memory safety because they're so low level. They talk directly to the hardware. They're ultimately there to let the programmer go nuts. And because of that, it can cause a lot of harm if you don't take into account what your code might do in the wrong hands. So this is a quote here by James Gosling. He's the guy who wrote Java. And he wrote Java because there were so many dumb bugs and security vulnerabilities because of memory problems, memory management. So he says Chrome, the Google Chrome, is like a giant piece of C++ code. And 60 to 70% of all the security vulnerabilities nowadays were stupid pointer tricks. And he said, I thought it's 30 years later and we're still there. We're still having the problems that drove him to write Java in the first place. So here's an example of one of these memory bugs. This is a line of code in, it's not actually WhatsApp, it's the dependency of WhatsApp, which is kind of sad because they didn't even write this code, and their bug, their app will actually crash and allow remote code execution because this GIF preview library called this code. Now, what's interesting here is realloc array. This is a double free, and you don't see the word free anywhere here. Now, a double free is where you try to free the same memory location twice, and that can cause the app to that make that memory location. You can end up writing arbitrary data to it and then using it to execute the code if the code is structured in the right way. So what's happening here is if you use a carefully crafted GIF file, this realloc array function will cause a double free because you can have 2 frames in a row with the size of 0. And by doing so, this realloc array will free the array, and then it will not allocate any data with the malloc. And so you get 2 frees in a row on the same address space. And then, so like you can have a GIF file where the first frame is the code you want to run, and then the next 2 are 0 frames, and that then causes the preview pane of WhatsApp to execute that code that was in the first frame of the GIF. And this is what happened with WhatsApp. There were nation-state actors that were using WhatsApp to install spyware onto people's phones, like human rights people and all sorts of stuff. It wasn't even WhatsApp's fault, but they had to fix the bug. So here's another one, also a memory example involving C++ code. This is Heartbleed. This is the line of code. That's all it is, just a mem copy. But this payload variable is very important. The problem with Heartbleed was the clients could lie about the payload variable size, describing how much data needs to be copied. So you could have a payload that's actually 0 sized and a payload variable that says 64K and as a number, right, of bytes. And this would allow an attacker to page through and get a copy of all memory on the client machine. This was a terrible, terrible bug. Let's talk about types. Now, a lot of people are using languages like JavaScript or Python or Perl that don't have these great guardrails to prevent stupid mistakes. Without types, you really have to do a lot more test-driven development. And who does the most exhaustive test-driven development? Who actually gets every one of the things that types will check for you? Almost nobody. So if you want your life to be easier, it's nicer to have some form of types, even if it's just TypeScript, something to improve your day so you don't get these silly bugs, especially with large code bases. This is, you don't want to have a road where there's no road signs before there's a big gaping hole of construction. And in modern languages, you can even get inline types where it uses the type to do type checking of your code at compile time. And then it removes those types, uses just bare types, the basic types of your platform or your language, to then not have any overhead to get that type checking. That's amazing if you can use it. So here's an example of a security flaw caused by not having strong types. eBay allowed people who had eBay listings to put some certain tags in their app. And they actually allowed script tags, but they wouldn't allow anything alphanumeric. So somebody figured out that they could come up with this thing called JS, pardon my language, JS fuck. And in this language, empty arrays can be evaluated into code because JavaScript allows that. So you can actually add together arrays and get A's and B's and 1s and 2s. And by chaining this together very, very deep, you can try on this JS whatever website, it'll generate this very small amount of code from a massive amount of array arithmetic. And so people could get around eBay's protections for their users and then commits cross-site scripting attacks using just this crazy code that because there's no type checking. So let's talk about injection. Now, injection is one of the most common types of bugs, especially if you're writing something that's not C++ or C. You're going to see this all over the place, all over the web. Everybody seems to have injection bugs. And ultimately, it's just another type error because you're treating user input as being the same type of like string or whatever as the rest of the string. And you're really making a false assumption about the input types, where the common solution for like SQL tags is to have a prepared statement. And what you're really doing is you're creating a new type that represents the user input so that you can treat it differently and you can validate that it actually is safe before you combine it together into one prepared query statement. So again, this is still another type error, but it's super common. It's all over the internet. Cross-site scripting is one of the most typical things I find in a review. Actually, one of the most insidious things, which you don't see as often maybe, is test code in production. So when you write your automated tests, it's very uncommon that anybody has any thoughts about the security or the permissions of the code and what it's doing. And so the one thing you don't want is to have your automated test code pushed out into your production app. And when I worked back at Mozilla, one of the worst flaws I ever saw was one of these. Fortunately, I stopped it before it got out to more than a small app with a couple hundred users. They wanted to push it to a very large app with millions of users. And I realized very quickly that anybody can install any arbitrary web extension with any app on the phone using the test code. So do not push your test code to production. It's notorious for security flaws. So at this point, I can take any questions, and yeah, we'll just see what we got going on here. Do we have any questions? Seems very quiet in the channel. Nothing yet. Okay. Yeah, I'll answer any questions about anything having to do with code security at this point. Well, I'm not seeing anything. Give it a few more seconds. I had a great time talking to you all about this. If I'd had more time, I would have gone into a little more depth on a few additional topics. There's so much to talk about in the security world. I highly recommend going to OWASP, looking at their manual and their checklists if you want to really deep dive into this. Awesome, awesome. Okay, so do I have any recommendations for a secure browser? That's a good question. So actually, one of the biggest guys who studies security, originally he said that Chrome was the only one that's secure, and I think last year, possibly, he said that Firefox had caught up and was actually as good, if not better, in some ways. It's tricky because there's sandboxing things that they're trying to improve. I would say either one is good. They're even better if you turn off JavaScript, but then you won't be able to use most modern web apps. Another question was just asked, which password manager is best? Now, if you're thinking about security, like the answer is almost always the thing that requires going to the internet the least. So if you can run like KeePass on your phone or on your device, then you're not sharing your passwords with the internet. But if you want something convenient that you're actually going to use, that's the most important thing. It's like having, they talk about having the camera that you carry in your pocket is the best camera you own because it's one that you're actually going to use on a daily basis. So if you have a password manager that you don't use because it's too inconvenient, it's better to have any of the big ones like 1Password, LastPass, BitKeeper. I think that's right. Yeah. So the key is make sure that you actually use it. Do I have any suggestions for an easy resource for someone new to application security considerations? That's a good question. So there are actually multiple ethical hacker trainings on the internet that will go into great depth. I forgot the name of the one. It's Red Team, maybe, is one of them. Yeah, there's definitely a lot of ethical hacker trainings on the internet, and you can read reviews about them, see what people are saying. And once you've done that, I highly recommend going to a security conference and trying out a CTF. Do I think WordPress WooCommerce sites can be secure by installing WordFence? It's a very good question. I will say there's a lot of WordPress sites, and a lot of them never get hacked. That doesn't mean that they're secure. Amazon actually outlawed PHP entirely. Well, before I was there, even like they still to this day, I'm pretty sure they don't allow PHP within the company because it's dangerous. But WordPress in general is one of the most rock solid PHP projects around. So yes, if you try to do it that way, it'll probably work for you. But there's no guarantees. Never any guarantees in security. Cool. It was great talking to you all. Thank you so much for having me. Awesome.